Just as we've learned to use Pythagorean theorem for finding the missing sides of a right triangle, we can continue to do that. If I have a perfectly isosceles triangle where the two side lengths are 2 and 2, they're the same. It turns out both angles in the corners are also the same. They're 45 and 45 degrees, and then you have the right angle of 90. So I want to find the missing side. So I would have my Pythagorean theorem, a squared plus b squared equals c squared. 2 squared plus 2 squared equals the hypotenuse x squared. 2 squared is 4, so 4 plus 4, 8 equals x squared. To undo the squared, I need to take the square root of both sides. And we're going to make a factor tree to put the 8 in the simplest radical form. 4 times 2, 2 times 2. Since I have a pair of 2's with a 2 left over, the x is 2 square root of 2. If I look at the next one, I have a side of 5, a side of 5, and a side of 5 squared root of 2. Well, I've already told you that this is an isosceles triangle, so we would assume that this side should be 5, 5, and 5 is 5 squared root of 2. But we could do our Pythagorean theorem to check. A squared plus b squared equals 5 square root of 2 squared. 5 square root of 2 squared is 50, and 25 squared plus 25 plus x squared equals 50. Subtract 25 on both sides. So we have x squared equals 25, square root of both sides, then we get x equals 5. So that was correct. There's a general case you can notice a pattern happening here. If both sides are x and x, it is isosceles. Both sides are always the same. And the hypotenuse then, if it was 2, 2, the hypotenuse was 2 square root of 2. If the sides were 5 and 5, the hypotenuse was 5 square root of 5, square root of 2. So if the sides are x and x, the hypotenuse is x times square root of 2. I can look at my examples. If the hypotenuse is 3 square root of 2, the x was replaced with the 3, which would make both sides be 3 of my isosceles triangle. If one side length was 5 square root of 2, the other isosceles side 5 square root of 2. And that would make the hypotenuse, I would need to take my x of 5 square root of 2 and multiply by another 5 square root of 2. So the x times square root of 2. Square root of 2 times the square root of 2 is 2, so it's 5 times 2, which is 10. The last one, the hypotenuse is 12. That doesn't look like an x times square root of 2, but it is. It's just disguised. So to go backwards, instead of taking the short sides times the square root of 2, I'm going to go backwards. I'm going to take the long hypotenuse side and divide by the square root of 2. And then we have to rationalize that, multiply by square root of 2 and square root of 2. So we end up with 12 square root of 2 over 2. And you can simplify. 12 halves is 12 divided by 2 is the same as 6. So both side lengths are 6 square root of 2. Again, if it's an isosceles triangle, the angles are 45 degrees, and 90 degrees. Then the same isosceles sides, x and x, would produce a hypotenuse of x times the square root of 2. Or if you have the hypotenuse, to go backwards, we would divide by the square root of 2 to find that short side length. Now we have our second type of special triangle. This one has angles of 60 degrees, 30 degrees, and 90 degrees. So it's a 30, 60, 90 triangle. Let's do our Pythagorean theorem to find the missing side. One side is 5 squared plus 5 square root of 3 squared equals c squared. So we get 25 plus 75 equals c squared. 100 equals c squared. Take the square root of both sides, and we get that the c side is 10. The hypotenuse was 10. We can try another problem. The hypotenuse is 8. The shorter side is 4, and we need to find that the longest leg side. So we have 4 squared plus b squared equals 8 squared. 16 plus b squared equals 64 squared. Subtract 16 on both sides, and we get b squared equals 64 not squared. 64 minus 16, which is 48. Take the square root of both sides to get b, but we need to make a factor tree because I don't know the square root of 48. So 48 is 6 times 8, 3 times 2, 2 times 4, 2 times 2. So I got a pair of 2s, another pair of 2s, and a leftover 3. So 2 times 2 would make 4. Square root 3 is my B side. Again, let's look for some patterns. I see a short side of 5 and a hypotenuse of 10. A short side of 4, a hypotenuse of 8. A short side of x, a hypotenuse of, double it, 2x. Then try to find that long side. Long side of 5, or a short side of 5, a long side of 5 square root 3. Short side 4, long side 4 square root 3. Short side x, long side x square root 3. So every time you know the short side, you can multiply by 3 to get the long side, or multiply square root of 3 to get the long side, or multiply by 2 to get the hypotenuse. So let's see, the short side here is 2, so the hypotenuse would be double, it's 4, and the long side would be 2 square root of 3. Just multiply by square root of 3. Other one, the hypotenuse is 38, so that means if I cut that in half, the short side would be 19, and the long side would be 19 square root of 3. The last one is a tricky question. The hypotenuse is 6 square root of 2. That means the short side would be half of that. Half of 6 is 3 square root of 2. And the long side would be the short times a square root of 3. So I'd have 3 square root of 2 times a square root of 3, which is a total of 3 square root of 6 for the long side. And now you have the last special triangle, a 30, 60, 90. If you have the short side, the long side is short times square root of 3, and the short side times 2 is the hypotenuse doubled.